Okay, to keep things moving along in this chapter, I've got quick little videos here on the titrations involving a weak acid strong base as well as a strong acid weak base. The two things that we've got to deal with here, there's still going to be a stoichiometry calculation similar to the strong acid strong base calculation we looked at yesterday, and there's also going to be an ice calculation component. Now, it actually doesn't mean we'll do stoichiometry first, then ice. Uh, in some cases, we're actually going to have to do an ice calculation first, depending on how much chemical is added. Then we might have to do stoichiometry, or we may have to do both. So it kind of just really depends upon the question and what they want us to find. So remember here, if we're doing a titration, the first one we're going to look at is we're going to start with a weak acid, and we're going to titrate with a strong base. So that means we're going to be adding the strong base into the weak acid. So we'll start out with a specific amount of weak acid. Strong base will be 0 milliliters, and then we'll move on from there. Okay? So on page 700, they do another case study where they're just looking at adding different volumes, changing the volume of the strong base, which is sodium hydroxide, and how adding that strong base will change the components. Okay, so if we look at the case study there, they tell us that we have 50 milliliters of 0.1 molar acetic acid. Okay. And they give us a K value, because again, at some point, we're going to have to probably do an ice calculation. And then they're going to start titrating with a 0.1 molar solution of sodium hydroxide. So as we go through these steps here, remember this, we saw this yesterday. The very first one you tend to see is, well, what's the pH if 0 milliliters of NaOH? Okay. Well, the pH if 0 milliliters of NaOH is simply an ice calculation. Right? We have 0.1 molar HC2H3O2, which is a weak acid. So therefore, we're going to do an ice calculation to find out what the resulting pH is. So in that case, that's all we do for part A. And you should be able to, they give the answer there in the book of pH of 2.87. Now, part B is we're going to start adding certain amounts of base. Now, whether it's a homework problem or the AP exam, they're going to tell you different amounts. And they're not going to make you solve parts A through G or H or whatever. They're just going to have you do certain ones. So, in this one here, they're saying, well, what if we add 10 milliliters of 0.1 molar sodium hydroxide? Okay. Well, here's what we do is we change everything into millimoles, and we make that comparison there. So we have, and we can just put this back up here so we have it all the time. The 50 milliliters times the 0.1 molar, this is 5.0 millimoles. We can always refer to that. I don't have to come down here and rewrite that number all the time. Now, 10 milliliters of 0.1 molar NaOH, that gives us 1 millimole. So now we've got a strong base reacting with a weak acid. Here's our stoichiometry piece. The strong base is going to react 100%. It's going to fully dissociate, and it's going to react with that base. So you could, this is going to be our limiting reactant. So before the reaction, the acetic acid had 5 millimoles. After the reaction, it's going to lose 1. So it's going to only have 4 millimoles. Why is that? Because this is how much base we had. It's the limiting reactant. So the NaOH had 1 millimole. It reacts all of it. It has none in the end. So now what we have, the acetic acid has 4 millimoles left over, now in a volume of 60 milliliters. 50 plus 10. Here is our new molarity for acetic acid. Now you notice in the book they leave it as 4 over 60. And then they set up the ice box, which you'll see on page 701. They don't solve for this fraction yet. I would suggest you actually just solve for the fraction and be done with it, so that you're not trying to figure out all that stuff. Just solve for the fraction, be done with it. Everything else applies from what we did before in ice. Okay? So from that point on, we've got to a place that we're familiar with. Now this stoichiometry piece is actually almost like the common iodine and the salt, in the sense that there's a shift that has to occur. There's a reset that has to occur. It's a different type of reset, but that's what we're looking for. Now part C, we're just adding 25 milliliters of 0.1 molar NaOH. So now what this equals is 2.5 millimoles. Okay. So hydroxide ions, after the reaction, we have 0 left. The acetic acid, after the reaction, it's 5.0 minus 2.5 millimoles. So we are 2.5 millimoles now over 75 milliliters of solution. This is our concentration. And now we go on to ice. And finally pH. And again, you can see how they work that out on page 702. Now what's significant about this, we've got half, this is the halfway point in terms of the acetic acid. Half is gone, so halfway to the equivalence point, halfway to in terms of getting rid of all the acetic acid. Then on page 703, you see part D. Again, they just did another a conversion factor. Okay. Now what we have here is in part E, they say 50 milliliters of 0.1 molar NaOH. So D, we're pretty good. E, we have 50 milliliters of 0.1 molar NaOH. And now we're looking at, okay, well, this is the equivalence point because this is 5.0 millimoles. So all of it's been consumed. So we've got something there we've kind of got to talk about. So at this point, what do we do now? Well, if we have all that consumed, what we've got is we've got sodium ions, we've got water ions, and we actually now have acetate ions formed. Now you remember here, we're adding a lot of extra base. So what ends up happening is, since all of the acetic acid has now been consumed, remember what the reaction was. it was consuming this and making C2H3O2 minus in water. So now we got a lot of this forming. We haven't been talking about it in terms of a reaction, but now we have to, because what's going to happen now is our reaction changes. We now have this that's going to start reacting with water. And what's going to have to happen is some of this acetate ion is going to start to reform into acetic acid. Now, how do we know that? Well, what we're looking at here is, in the acetate ion, we actually are going to produce 5 millimoles in 100 milliliters. Water doesn't matter. We have 0 acetic acid. If it's all consumed, okay, all the hydroxide's consumed, we have nothing in the beginning. Now what this means is it's actually going to work its way back to producing some. So we've maybe crossed a line, and now we're going to work our way back. So what we have from this point on is an ice calculation. The last thing you've got to pay attention to is, since now we're talking about the acetate ion, this is Kb. So we have to, when we're going through our ice calculation, remember Kw equals Ka times Kb. Now this switchover, once we're at the equivalence point and things like that, this gives us issues that we've got to talk about. And again, sometimes people don't necessarily see this connection where we flip over. Okay? Then the last thing that we'll look at is they just have one for F and then for G. And again, now what we have is we have an excess amount of hydroxide ions. Okay? So you can see on page 704, what we have on that problem there is we've added excess hydroxide ions. So what we now have is we have a stoichiometry problem. And the stoichiometry problem is simply saying we now have excess hydroxide ions in a new volume. So now what we have is, in F, we now have 60 milliliters of a 0.1 solution. And then in G, we have 75 milliliters of a 0.10 solution. So what we end up having since from the beginning is we end up having 1 millimole in excess. And in F, that number increases even more, very similar to what we just did here. Well, now it's 1 millimole in excess over 110 milliliters. And so now we just simply have a concentration of OH, which we now simply can go to pH. And that same thing applies here in terms of now we have 2.5 millimoles more over, in this case now, 125 milliliters. Go to OH, go to pH. Okay. I know we'll have to spend a little time at this crossover point back here like in Part E, but I wanted to kind of show you an example of that so you kind of get a feel for why we're doing the things that we're doing.